Right. So let's see if we can go over some of these questions, right? And if you got to look at those questions, right? I'm going to open up a final exam for 190. I think I have something here. Let me see. 190. Yeah, they have a final exam from spring 2018, which I believe is not on the website, right? So let's take a look at the spring 2018 for 190, and I'm going to highlight the ones that with red the ones that we know how to do so far, and with green the ones that are in these type of questions that I'm asking. So in red, so far we should know how to do the first one, right? That's a linear equation, so that's a check. The second one is a system of equations. You have seen it before, but we haven't talked about it here. There are going to be about like 3 different strategies to solving systems of equations, and I can tell you some tips on what will be useful depending on what you want. The number 3, we don't know how to do that, but you've probably seen it. What do we mean by coterminal angle? And number 4, the area of a sector. You might remember doing something like this, but right, you have to remember it now after we cover it. Number 5 is sketch the graph of g of x. G of x is a third degree, right, polynomial. So what would be the first step? To factor it out. And then figure out the zeros, check where it's positive, where it's negative, the end behavior, and that's exactly what it tells you. Make sure your graph shows all intercepts and exhibits the proper end behavior. So you don't want to say that it goes to infinity as x goes to infinity if it doesn't, right? So we should know how to do this one as well, and I'm going to circle it with green because this is also in these sections that we are asking you right now. Okay? So what about number 6? The net change and average rate of change of a function between two t values, t equals 2 and t equals t equals 2 plus h. Yeah, we should know how to do that, right? Right. Number 7, find the domain of a function like that one. We should know, right? Yep. Definitely. Number 8, that's gonna be when we talked about trigonometry next week. Number 9, sketch the graph of 1 minus 2 to the x. State the domain, range, and asymptote. Label at least 3 points in the graph. That one we haven't covered that yet. This is a exponential a graph. That's what we're going to cover it after we all go over these questions, right? Number 10th, find an equation of the line passing through the points 1, negative 2 and perpendicular to the line. X plus 2y equals 6. We should know how to do that, right? So that's 10. Number 11th, what do you guys think? Should we know how to do that? Yep, good. Number 12, that's exponents, right? Yeah, the rules for exponents. Number 13th, can you solve for capital M? I think I asked you this question in a quiz, right? Yeah, and it was in your homework. Yeah, so this one definitely. We call these type of equations where you are trying to solve for one variable in terms of the others, we call them literal equations. That's the name that we give to this topic. And you find a lot of these in physics, chemistry, right? And a lot of it, right? Like if you know how two variables relate, you can solve for either variable and see how it will be affected by the other variable, right? So that's 13. Number 14th, sketch the graph of these function by indicating how a more basic function has been shifted, reflected, stretched, or compressed. Label all intercepts and the vertex of the graph. Do we know how to do that one? Yeah. So the most important thing will be the plus 3 is shifting it up, the x minus 1 is shifting it to the right, and the negative 1/2 in front of it, because it's negative, it will be reflecting it, and the 1/2 is going to be shrinking it vertically, right? Yeah, so it's not something that you want to worry about. The stretches, yeah. So the most important thing will be, do you know the vertical shifts? 3, yeah. Do you know the horizontal shift? Yes. And the negative sign in front of the 1/2, right, tells you that it's being reflected. The 1/2 is going to be not going to matter when you sketch this much, yeah. But so the most basic ones will be the shifts the vertical, horizontal, and the reflection. They do ask you here to indicate if it was stretched or compressed. So we talked about that, right? But it's not. I wouldn't if I was having issues with knowing when it was shrink or stretch, I wouldn't be worried about that specific. I could still give you a really good sketch without that, just looking at the reflection and the shifts. And they ask you to indicate how a more basic function has been shifted. So you have to get used to saying, okay, the first thing that will happen will be the reflection. Second thing will be either the vertical shift or the horizontal shift, and finally the last shift. And then if you want to mention about the compression there, you can say that it's being compressed by a factor of 1/2 vertically. Yeah. Mm-hmm. So that one we should know how to do. Yeah. And and I'm asking in the quiz that you just took, I asked you like 1 or 2 questions, right, from shifting a graph. What about 15? Should we know how to do 15th?
Yeah.
Yes. Yeah. What about 16th? Definitely, right? What about 17th? Not yet, right? Yeah. But hopefully you have seen something like that, right? Without the calculator, you have to know how to do that. Yeah, we're gonna talk about that. And number 18th, that's what we are working on right now. Right? So this one, I'm gonna put a circle on green to tell you that this is what we are doing right now. And number 19th, these equations, we should know how to solve them, right? We should know. So this one, I'm gonna put this next to it. What about 20? 20, we don't know how to do A yet, right? Maybe after today we're gonna talk about that. But for B, yeah, we can definitely do B here. This one. What about 21?
Both of them.
Yeah, we should be able to do both of them. So look at how many things we still haven't talked about. We have 2, 3, 4, right? 5, yeah, 8, 9th, right? 17th, and 20, part A, right? So we cover a vast number of topics, but we still have yet to cover a few more, right? So what happened?
Is the final going to be the same length as that?
Yeah, about 21 problems. Yeah. But some problems have A, B. The reason why they make it 2 hours and 15 minutes is that you have enough time to show what you know, right? And some people finish in 1 hour and they say, there's nothing I can do here, or they just leave. And it's like, you don't want to be that student. You want to take all of your 2 hours and 15 minutes. Make sure that you write, double check your answers, make sure that they're correct, and so on. If there's one student that from last year in CPAS, where I told him, you have a horrible handwriting. It's like, if I'm grading your exam, I'm used to grading your exam, but these other individuals who are going to be grading your exam, they have like about 5 seconds to decide, right, whether you get the right answer or wrong answer, and give you partial credit. And with your handwriting, they will have a lot of hard time. And he didn't he didn't continue to do this mistake, right? He improved on it, but I mean, you don't want to be that person where it writes all over the place and it's hard to find your answer. You want to be that person. I give you boxes in the exam, right, so that you can write your answer there. In the final exam, they don't give you those little boxes. You have to just box your answer yourself. It makes it very easy for whoever is grading it. Like, here is my answer. But anyways, let's go to the questions that we have here. Let's start off with number 1, right? So let's move everything down this way. Okay. So find and simplify this composition, f of g. So let's do a bit purple this time. So f of g of x is going to equal to f of g of x, and this will be f where g of x is x plus 1 over 2x minus 6, and this will just be 2 times x divided by 3x minus 4. And if you remember what we did in this step, we replaced, right, in those empty spaces, we are going to replace that with, Yeah, so with x plus 1 over 2x minus 6, right? Because that will be the input of the function f now. And so it will be x plus 1 divided by 2x minus 6. And our next step probably will be that 4, we can multiply that with, 2x minus 6 divided by 2x minus 6. And now at this step, we just cancel all the denominators, right? By canceling all the denominators, I told you that there is a problem. We are assuming that those denominators cannot be equal to 0. But that's not something you have to worry about that here. But just in the back of your mind, you have to think, what if that was 0? Then I wouldn't be able to cancel it. It would be a value where this expression is undefined. So what do we have here? So here, we're going to have 2x plus 2 on the numerator, because I'm distributing out the 2. And I'm going to have 3x plus 3, because I'm distributing out the 3. And when I distribute the negative 4, I'm going to have minus 8x plus 24. Yeah, plus 24. So what do I have in the numerator? It's 2x plus 2.
2x plus 2 and negative 5x plus 27.
Plus 27. There you go. And this will be my answer here. You usually box your answer, then it's easy to follow the work. All right. So what about for number 2? Right? Yeah. So let me move everything down. Let me just move this thing down. There we go. So for number 2, we have f of g of 2. F of g of 2. What is g of 2? Plug in 2 into g.
Negative 3.
Yeah, so on the numerator, we're going to have like what?
4 minus 1. Right?
So it's 3, right? Divided by negative 1. So this is f evaluated at negative 3. And what is that going to be? That's going to be, so it's negative 9th plus 1 divided by negative 3. So that's negative 8 over negative 3. So that's just 8 over 3, right? And you don't have to write your answer as a mixed number. This is perfectly fine. Nobody expects you to do that. But if you had like, 16 over 6, you want to simplify that, right, as 8 over 3. You want to make sure that your answers are in simplest form. Right? And what about number 3? Let me move this up first and then down. There you go. So what about for number 3? To find the formula for the inverse, we start by calling our function y, then switch the variables right around. So this will be first y equals to 2 minus x over 3x plus 1. We are going to say that x equals to 2 minus y over 3y plus 1. Have you guys ever encountered in your math class or a statistics class the linear regression line, the line of best fit? You ever heard the data and the line of best fit that goes through the points? This is coming by trying to find an inverse of something that is not invertible. In linear algebra, the best way that we can solve a system like that is by the best approximation, and that's that line that we get from it. It's like trying to find the inverse for a system to find its solution, but the system is not invertible because it doesn't have a solution. So what we do is we modify it so that we get the line of best fit from an equation like that. It's like it's what we're doing here, but in a bigger picture. And it's nice that when you can't do it, the best way that you can do it is just get the best result possible. And but in this case we can. So cross multiply. So that'll be 3xy plus x when you cross multiply equals to 2 minus y. And we're trying to solve for y, and this is the step where students make mistakes. There are two y terms, right? You have to put them on the same side. So I have 3xy plus y equals to 2 minus x. Right? Factored out the y, and this will look like this. And finally, and we are going to call that formula the inverse, right? This is going to be 2 minus x divided by 3x plus 1. And this one gave us the same function as we started with, right? So what does that mean? That it is its own inverse. And how can you double check your work for this one? You can apply, this is a check.
Inverse property.
Mm-hmm.
G.
You can check your answer by applying the inverse function property. So you had two things. Number one is f composed with g of x will equal to x, and number two, g composed with f of x equals to x. And we had a little line after that. The first one, he says whenever x is in the domain of g, and the second one whenever x was in the domain of f. And these f and g are inverses, right? F and g are inverses. In other words, two functions are inverses if the following happens, right? We shouldn't check both of them. We should just check one of them to see if our answer is correct. But if they ask you to check that they are inverses, you should do both, right? But here we just briefly checking our answer to see if it's right or not. So what we want to do is we want to do f composed with f inverse, right? That's our function up there of x. So this will be f of 2 minus x over 3x plus 1. And this will be, let's see if this is right. It will be 2 minus, right, x divided by 3x plus 1. What are we replacing the parentheses inside of these parentheses with?
2 minus x over 3x plus 1.
Yeah. So in here we're going to have 2 minus x over 3x plus 1. And the same thing here. 2 minus x over 3x plus 1. And our next goal is to multiply the 2 and the 1 by these guys right here. So there was a 2 there. We should multiply these 2 by 3x plus 1 over 3x plus 1. And this 1 should be multiplied by 3x plus 1 over 3x plus 1. What do we get out of that? Now that we can cancel out the denominators like this. Like that. So what are we going to get on the numerator when we do this? So let me move this. Yeah. So on the numerator, ouch. Yeah, we're going to distribute out the 2, so we're going to get 6x plus 2 minus 2 plus x, because we are distributing out the 2 here, and we are distributing out the negative there, like that. And on the bottom, what are we going to get when we distribute out the 3? 6. 3x plus 1. What do we get on the numerator? The 2's canceled out, so we get 7x. And on the bottom, what do we get? The 3x cancels out, so we get 7. Does the 7 cancel out? Yeah. So it is. Is it always true that the function f will be its own inverse? No, it just happens like that, right? But it happens sometimes. And
So if the two functions are inverses of each other, what does that mean? That means if it's exactly reflected over y equals x.
Yeah. So if you were to graph these function, f, and you draw the line y equals x, it's its own mirror reflection about the line y equals x. So when you find the inverse, you get nothing new. It's exactly the same. It's something like if you have an even function and you reflect it about the y-axis, you don't get anything new either, right? So so in this case, it just happens that this is its own reflection about the line y equals x, right?
So why did you add 3x plus 1 for x plus something?
Yeah. So I get the same denominators.
Oh, you multiply.
Yeah. So I'm trying to get the same denominators. Yeah. And because all of the little fractions have the same denominators, I can just cancel it out. Right? All right, so number 4 now. Yeah, number 4. This is what we were doing yesterday, right? With the parabolas and so on. How will you start off with this here and get the vertex form from here?
Complete the square.
We complete the squared, right? And I told you a second method, right, where you just memorize the formulas for h and how to find k and then a, and you plug them into here. But I told you that that works now, but later on is like you need to eventually get used to completing the squared. So this is what we have. We have f of x equals to 2x squared plus 2x plus some blank here minus 6 plus some blank on the left side. On the first blank on the right side, what are we going to add? 1. And on the left side? 2. So we have 2 plus f of x equals 2 times x plus 1 squared minus 6. And all we have to do is solve for f of x by subtracting 2. Yeah. So f of x will be 2 times x plus 1 squared minus 8. Yep, minus 8. So we let me box this, right? This is the vertex form, right? Vertex form. He says sketch the function, but I want to write a little bit more before I sketch the function. What will be the vertex for this one?
-1, -8.
The point -1, comma -8. We change the sign of x plus 1 into -1, but the other side we leave it as it is, right? And what will be the intercepts, right?
Y is -6.
Yeah, so let's see. So let's find the x intercepts. If they exist, last time yesterday we saw an example where they didn't exist. So possibly, the y-intercept always exists, but the x-intercept, you might not have any, right? Because it might not ever cross the x-axis, right? But it always crosses the y-axis all the time. And so here's an x-intercept. How do we find this? We let y equals to, and that is our original function, right? This, but I would like to use the vertex form for this one. So I will be having 2 times x plus 1 squared minus 8 equals to 0. So I have 2 times x plus 1 squared equals to 8. That means x plus 1 squared, 4. I take the square root on both sides. I get x plus 1 equals to,
Plus or minus.
plus or minus 2. And so x will equal to -1 plus or minus 2. That the two possibilities are that x equals to
1, -3.
-3 and 1. So these are the x-intercepts. What about the y-intercept?
It's up there in the first general form.
So for the y-intercept, we set x equal to 0, but we do this in the original, right? The original function. If you do it here, you get the same answer, but it's just better just to do it in the original one. So if you set x equal to 0, you're gonna get that y is equal to -6. There. So we have enough information to sketch our graph. Let me do it here. Let's see. There we go. Yeah. So let me just get this. There we go. So imagine that we have the y-axis here, and we have the x-axis here, and maybe continue this a little bit more. And here's y. What is the vertex for this one?
-1, -8.
-1, -8. So here is -1. -8 is going to be down below 1, 2, 3, 4, 5, 6, 7, 8. -8. So maybe it will be a point somewhere over there. Let me put this with this color. There we go. Now, would the parabola be facing up or facing down? Facing up, right? So that's why I left a lot of space up there, so we can do that. What will be the x-intercept in this case? Yeah, the x-intercepts will be
1 and negative.
yeah 1 and negative 3. So let me just put negative 2, negative 3, and then 1 and 2, but I'm not going to need more than that. So here is that, and here is this one here. And now the y-intercept here will be negative 6. So this will be negative 6, like this. Like that. So the graph has to pass through these points right here. And let's connect them with a like a parabola shape, right? So we're going to have this like that, and we're going to have this. Yeah. My friend was like, your parabolas are always like symmetric, and my parabolas are always like slanted. Yeah. So just draw more parabolas. Yeah. Yeah. So we should label all of these points, right? So this point here will be 1, 0, negative 3, 0, and then this is negative 1, negative 8. And let's see if we can write all of the information that they ask us. What will be the domain for this?
All real numbers.
Mm-hmm. All real numbers. The range from
Negative 8.
yeah, from negative 8 to infinity. We start off from the minimum value, right? Negative 8, including it, all the way to infinity. And what will be the intervals where f is increasing?
Negative 1 to infinity.
Mm-hmm. It's increasing from negative 1 to infinity. And f is decreasing. Mm-hmm. From negative infinity to negative 1, like that. So hopefully that makes sense. Let's see if you answer all of the questions, right? So write the vertex form of this parabola. We did it. Sketch the function. That's our sketch. Label all intercepts and the vertex. We did that. State the domain and the range. We did it. Find the intervals where f is increasing and on which f is decreasing. We did that, right? So is that okay? Yeah. Okay. Great. And then we have the last question now, right? So are there any questions for this one? Yeah. Question? Yeah, so it's increasing from negative. So these are the x values, right? So starting at negative 1, you're going to be at this point right here. And if you start walking to the right, after this point, you're going to start rising up. So you're increasing from negative 1 all the way to infinity. But if you are looking at the left side of this, imagine that you are anywhere on the left side of this parabola, say somewhere here. If you walk to the right, always walk to the right, then you decrease. So as you move from left to right on the parabola, here you're going to decrease. But as you move from left to right, after x equals negative 1, you're going to increase up.
Once you get the vertex, right, can't you just tell by the vertex, like, which side would be increasing?
Yeah.
You don't have to really graph it, right?
No, but they will require you to graph it. Sketching is part of the problem. Yeah.
So, like, is the final going to be time for...
2 hours and 15 minutes. Yeah. So it's
That's 30 questions.
no 21 questions approximately. Sometimes they put 22, and then you have 2 hours and 15 minutes. You have to answer all of the questions, and yeah. So some of the questions have parts, but they're not a big deal. You have to have enough time to double check your work because it's the final exam. But, yeah. You had a question, Yalo?
Yeah, so open up like, you scroll down a little.
Up like this?
You open up like in the homework, they give you the function of like 2x squared plus 4x minus 6, and they say like express f into a standard form.
Mm-hmm.
What does that
Yeah,
mean?
so they use mean vertex form. So for some reasons, the book that we had before, the previous book, said that they call these the standard form, and the other one, yeah, and then the other one they just call it general form or something like that. Yeah, but our book calls this the vertex form. But so if they give you that, right, and they ask you to write it in standard form, you just write the other one. Right, write the other one down. Yeah. So
What if there's a negative sign in front of 2?
this one.
You know, in the standard form. Right, there are
Yeah,
questions like
from
that.
from
Negative
the beginning.
square.
Yeah.
Yeah, so you still do the same thing that we did here. We factored out the -2. So this sign would have changed to -2, right? Because you factored out -2. So all the steps are exactly the same. These -2, if this was -2, this would have been -2, indicating that the parabola, instead of facing up, it would have been facing down like this. When you try to find the x-intercept for that one, you don't have any x-intercepts because it will be going the other way around. Yeah. So just be very careful on that. But the same steps will be taken. You factored out the -2 from the x terms. You add this constant, and the other side, because of this negative, you would have been subtracting the value 2.
And what if it was like backwards, like -6 minus 4x minus 2x squared?
You can rearrange it like this. Yeah. Yeah. Just
Keep the signs of the.
yeah. You just don't change the signs. Just rearrange it. Yeah.
So if like there were no like a 2 right there, it was like -x squared.
Uh-huh.
I just have to multiply the whole thing by negative, right?
Yeah. So if it was just -x squared, what you can do is you can multiply everything by negative, so the negative moves on the left side, or you can factor it out the negative, which I would rather factor it out. Yeah. If it's not 1, I'll just whatever it is, I just factor it out. Yeah.
So you just keep the signs and you add everything, add all the terms,
Yeah. So if you rearrange the terms, just keep the signs as they are, right?
and just
Yeah.
add.
Mm-hmm. Yeah. Right. So for number 5, right? For number 5, so here we have a polynomial, p of x, and from your homework, you notice that sometimes they give you the polynomial in factor form. In this case, we have to do that for ourselves, but it's not a big deal. They cannot give you something that is very big for you to factor, because we haven't developed those techniques. Not in 190. We developed them later on. What if you have a 7th degree polynomial and you want to factor it out? You have to have some techniques of doing this, and there are techniques to knowing how to factor this out. And so here is a 3rd degree polynomial, p of x. Let's factor this out. So we have x cubed minus 4x. So that maybe we can factor it out x. And if we do that, we're going to have x squared minus 4. Can be factored out the x squared minus 4?
X minus 2 and x plus 2.
X minus 2 and x plus 2. And that's it. This is the factor form of x cubed minus 4x. And so what are the zeros for this thing?
-2, +1, 0.
Yeah. So and we put them on the number line. And this number line is representing the x-axis, right? And here is 0, here is -2, and here is +2. Choose a test value, say between 0 and 2, make your life a little bit simpler. Like 1, plug in 1 into it. Is it positive or negative? Negative. So you don't need to test values. You can just, from here you can tell that it will change signs everywhere, right? Everywhere. Because we look at the powers for each of the factors, and the powers are odds, right? So they will always change. So what does the negative tell you? The negative tells you that the function lies under the x-axis, right? And the positive will mean that the function lies above the x-axis. So how will the end behavior look like? The end behavior for this one will go to positive infinity on this side and negative infinity on that side. And just a rough sketch, it will go like this, yeah, like that. So you can have a rough sketch of how this is going to look like. But you have to put this a little bit nicer in a graph. And let's do that now. So here is, and you're not trying to get the perfect graph. You're just trying to get a graph that makes sense, right? So here is x and here is y. Here is 0, -1, -2, 1, and 2. And we know that the graph is going to pass through -2, 0, 0, 0, and 2, 0, because these are the zeros of the polynomial. And what will happen between 0 and 2? The function is negative. Yeah. So the function here is negative like this, and is it gonna cross the x-axis at 0? Yep. And it's gonna have to come back down to this guy here like that, right? And you see at 0, I didn't made it tangent to it like we did yesterday, right? Yesterday we made it tangent to it because the degree was 3. It will cross the x-axis, but before it crosses it, it's like getting tangent to it. But here he's not. He's going to cross it out, but the power for this one is 1. Every time the power is 1, it's never going to be tangent to it. It's just going to cross it out. Yeah. So then after 2, this function will keep increasing. Before 2, the function will keep decreasing, like increasing in well, it's gonna head down that way. Yeah. Let's see if we can write a few more things here. So f is positive. It's not f, it's p. That's how we're calling it. Yeah, positive on, and p is negative on. Where will we p be positive on? Perfect. Yeah. There you go. And is negative on negative infinity to union from. And that's good. So let's see if we miss anything, right? They ask us sketch the graph of the polynomial p, label all intercepts. So maybe that's what we could do now. Label all of them. So this is 0, 0. This is 2, 0. And 2, 0. And this one will be negative 2, 0. Right? Like labeling what they are, like that.
Wouldn't you use brackets?
Well, at the zeros, the function is 0. And 0 is neither positive nor negative. It's like, when is it positive? It's just, yeah. And guess what will happen if you take the absolute value of the entire polynomial? Then when you take the absolute value of an entire polynomial, the output cannot be negative. So what will happen to the parts that are negative? They will be reflected over the x-axis. And what will happen to the parts that are already positive? They will stay positive. So if you take the absolute value of a polynomial, this little part of it is going to go up this way now. This little part here is going to go that way. And in calculus, that's fascinating because when you do that, when you reflect this little piece about the x-axis, all of a sudden you create a cusp, a little sharp edge. And there, the tangent line doesn't exist, not the way we think about it. So in calculus, when you every time you have a cusp or a sharp edge, we are interested on what happens to it in terms of rates, tangents, right? And but for now, yeah. So let's take a look at the factors here. This is one of them. Here's another one, and here's another one. The first factor x is what gave us 0. This one. The second factor is what gave us positive 2. And the third factor, when you set it equal to 0, x plus 2, it will give you negative 2. But look at the exponents for each of these box factors. The exponents is 1. Every time you have an odd power for these factors, the signs will change. So let's take a look at 0, for example. The sign on the right side is negative. We test it out by plugging in 1. You don't need to test a point on the left side of 0. You know that it's going to change because the power from the 0 factor is odd. Right? You don't have to test it out. Yeah. So here's another example, and then we move on to the next section. What if I ask you to sketch the graph of the polynomial p of x equals to, say, x cube plus 9x, like that. And I do the same thing. I ask you to label all intercepts. And indicate where p is positive and where p is negative. Again, you want to indicate the proper end behaviors, right, of this. But let's start off with p of x here. P of x, in this case, is a polynomial of third degree again. So x cubed plus 9x. And we factored out the x from this first, right? So we get x times x squared plus 9. Can we factor x squared plus 9 a little bit more? We can't. Yeah, we can't. Yeah. Yeah, we can't factor that out. Yeah.
Because it's not a negative, like.
But there's only
negative
1
nine.
0.
Yeah, so that's why we can't factor it out.
So there's only a 1 0 point to the 0, right?
Mm-hmm. Yeah, so the other factor is not going to give you any zeros. So there's only 1 0 possible. If you try to make the other factor equal to 0, this guy here, okay, you have x squared plus 9. You try to set it equal to 0. You get that x squared is plus minus the square root of negative 9, which is not a real number, right? Yeah. Value, yeah. So there is only 1 0 in this entire thing. That 0 is x equals 0, right? Like this. So here's x and here is 0. And so when you're testing values for this one, it's very simple. All you have to do is test to the right and test to the left. The factor that gave you a 0 has an odd power. So
One of them.
yeah, it will change on it, right? So what will be the sign on the right side of 0?
Positive.
And on the left side?
Negative.
Yeah, like this. The other factor, x squared plus 9, if you think about it, no matter what you plug in for x squared plus 9 can never be 0.
So
Or
it's just a regular cube root function.
yeah, well, let's see here. So the end behavior for this one will look like this. To the right side is positive infinity, the left side is negative infinity, and in between them is going to cross 0 in it. So it will look like the cubic function. It might do some weird stuff after that, but overall, that's as good as we can get with this. So here is here is what we have here. The 3, yeah. So so here's the y-axis, here's the x-axis, and here is 0. And our function will pass the 0, 0, and after that, and the way that it passes 0, by the way, is not going to settle down like the cubic function. These guys, when it crosses the 0, is just going to be like this, right? Like this. Like this. And probably it will look like this. But it doesn't have to be tangent to the x-axis when it crosses 0, because the power of the 0x here, the factor x, is 1. If it was 3, then it will have to be tangent before it crosses the axis, right? Before it, anything higher than like anything higher than 1, like 3, 5, 7, you have to cross the x-axis but being tangent to it, right? So here is f is not f, p is positive, right? On p is negative. So where is p positive? From 0 to infinity, yeah, and negative from negative infinity to 0, like that. And the intercepts that we only have 0, 0 as the only x and y intercept, right? Let's check this in Desmos, right? Let's check this on ouch. Desmos. Great. Let's see, this is what we had. So f of x, or the polynomial that we had, was x cubed, right? Yeah, but we factor this out, right? X times, yeah, x squared plus 9, right? That's how we factor it out. And when we take a look at this on the right side, look, it just crosses the 0, right? And it looks like a straight line, but it's not. It's really slanted, right? It's really weird. Yeah. It's really straight, right? And the numbers get really big very fast. Let's zoom into this a little bit more. You see? So you can see that it looks like what we have over here. Right? But do you see that that's the only 0 on the graph? Yeah, you see it?
Because it only has 1 0, it isn't tangent to the x-axis.
Yeah, so no, because the power of this guy here, let me box this. This one, this is what gave you this 0 in the beginning. The other factor didn't give you any zeros. What is the power for this one? 1. So it will cross the x-axis because it's an odd power, right? It changes signs from negative to positive. If it had a power of 3, before crossing it, it will be tangent to it. If it had a power of 5, the same thing, yeah. But everything that has a linear like exponent of 1, it will cross it in this way. And if it was from positive to negative, it will cross it this way, right? But put a power of 3, and all of a sudden when it crosses it, it has to be turned into it and then cross it. Little details there. But great. Now for the next section will be section 4.1. And I will introduce it, maybe do one example, and then we take a break, right? So for 4.1 will be exponential functions. Yeah, exponential functions. And what we're going to talk a little bit about this will be, suppose that we are considering the form like this one, 2 to the x, for example. Let's put this as f of x. Suppose that f of x is equal to 2 to the x. And there is a story that I heard, and most of the stories I heard, I questioned them. But there's a story about the man who invested the chessboard game. They say that the king was very happy with the game, and the king asked if he can do anything for this man that invented the chessboard game. And you know how many boxes are in the chessboard game? 64, right? 8 by 8. And so the man asked that for the first grain, for the first box in the chessboard, starting from the bottom, to put 1 grain, and the next one to double it to 2, and for the next one to double it to 4, and for the next one to double it to, right? Yeah, 8, and so on, to keep on doubling until for every box in the chessboard to put grains like wheat grains. You know by the time he gets to the last one, right? The last box. Just the last box. How many grains will the last box have? 2 to the
64.
Yeah, 2 to the 64. Well, it's 2 to the 63. Yeah, because you start with 2 to the 0 to give you 1, right? And then 2 to the, so it will be 2 to the 63. Well, it's still going to be enough. Let's see what this number is, and it is a machine that supposed to work. This is the number that I don't even know how to read it. Yeah. It's a huge number. Just that box, the last box. Imagine if you have to add all of them. If you had to add from the first box 1 plus 2 plus 4 plus 8, right, plus 16, and all the way, and then the king says, if that's what you want, we can do this. And he asked his servant to meet the wish of this person, and the servant came to him and says, we can't do that. That's impossible. Even with all of the grains in the world, we can't do it. And at that time, and then the king got frustrated and executed the man who invented the game for chess. I heard that story. I don't know if it's true. You can verify that, and yeah. But I'm telling you that I don't know if this is a true story or not. But oh, look, it reads it for us, right? 9 quintillion.
9
Yeah.
billion.
Yeah, 9 billion.
Billion.
Yeah, but it's just that last box, right? Yeah. So you can imagine that just having 64 spaces, right, with a game board of chess, it increased really fast, exponentially, right? And if you ever hear the stories of bacteria, for example, bacteria has this exponential growth, but they're tiny little things, right? And if they don't control this, right, duplication of bacteria, then it will probably kill or become a pandemic or something that will be irreparable. But for now, just imagine this function here, and let's create a table of values. I told you it's not very useful, but let's come to see how this will behave. And so here is x, here is y, and yeah, let's see if you can plug in some values and get an idea how this is going to look like. I'm going to start from the middle like this, right? So you can see that I'm going to add values a little bit up there. But I'm going to start with 0, then 1, then 2, 3. Get a sense of where this is going. 3, maybe. Yeah, this is good enough. So here's 3, 4, 5. What will be 2 to the 0 for when we plug this into the? Yeah, that will be 1. And 2 to the 1, 2 to the 2. Yeah, 2 to the 3. Yeah, 8. Yeah, 16. 32. Like that. And now let's go backwards here. So let's put here. Let's add these sections here, up here. And there you go. So what will be if we plug in -1, -2, -3, -4, -5? So plug in -1.
1/2.
Yeah, 1/2, right? Plug in -2. 1/4. So 1/2 is 0.5. 1/4 is 0.25. And this will be 1/8. 1/8 I believe is 0.125, right? And then this guy here is one of it, or 16th. I don't know. I think it's 0.0625, something like that, right? And then this will be 1/32, like this. But just imagine if you keep on plugging bigger negative numbers, like -6, -10, -100, -1,000. Will you ever hit a negative value?
No.
No matter what negative number you plug in, you will never ever get a negative result on the right side, right? On the right column. Okay, what happens as you keep on increasing the negative values?
Closer to 0.
You're getting closer and closer to 0. We're going to call that an asymptote, right? I heard this in a train station. The woman told a man, hey, be asymptotic. That's it. Yeah. It's like don't touch me. You can get as close as you want, but don't touch me. Yeah. That's what I understood. Yeah, but I was like, wow, that was like, yeah, a nice term to use. So we say as x goes to negative infinity, right? Let's write this out before I forget here. So as x goes to negative infinity, right? The function goes to, yeah,
0.
the function gets closer to 0, yeah. 0. So before, for polynomials, as you go to negative infinity, you either went to positive infinity or negative infinity. For this one, all of a sudden is settling down to some value, right? And this is settling down to 0. And what about the other side, right? As x goes to positive infinity, then the function, yeah, gets larger and larger, right? But let's say it goes to, yeah, positive infinity. You guys agree with that? Yeah, right, definitely, right? And we talked about adding, right? What will be 2 to the 63? That's a huge number, right? Yeah, and so let's see if we can sketch these very briefly enough, but get a good idea of where we're heading to. And I'm gonna at the end we can take a look at some of the terms that we managed to already talk about, like before. So here is x, here is y, and what will be the value of the function at 0? 1. What will be the value of the function at 1? 2. So it will look like this. Here. What will be the value of the function at 2? At 3? At 2, sorry.
4.
Yeah, at 2 or 4. Let's see. Yeah, let's see. It will be somewhere over there. But you can imagine what will happen after that, right? It's going to just increase really, really fast on the right side like this. Let's put this with purple, like this color. So it's going to start rising up. If you compare this with the parabola, the parabola is not close to this. The parabola is always going to be underneath. Even if you start with a parabola above this, eventually the parabola doesn't grow fast enough. The exponential functions are the fastest growing functions ever. We say that nothing grows faster than an exponential function until we introduce a factorial. And then you modify the exponential function and it beats the factorial. The factorial grows really fast, right? But the exponential function can be modified and it even grows faster than that. So you can modify an exponential function and it keeps on growing really, really, really fast, right? So what happens on the left side here?
Goes down towards
Yeah,
zero.
it goes down towards zero like this. It never gets to zero, right? There is no particular x value that you can plug in so that you can get zero. So based on this graph, right, what will you say the domain for this is?
All real numbers.
All real numbers. You can plug in any negative value that you can think of and any positive value that you can think of. What will be the range for this?
0 to positive infinity.
Yeah, but we have to be careful here.
Can't include 0.
We cannot include zero. There's no particular x value that we can plug in into a function to get zero. Right? So these here will be everything from 0 to infinity, right? And so what about an x-intercept?
1. Oh, there is no x.
There are no-
Yeah, no x-intercept. There's none. What about where is the function is with the y-intercept, right?
1.
The y-intercept will just be, I'm gonna put it like this, 0, 1 is a point. And so every time is like 0, something or 1, something like this. It could be an interval or it could be a point. So I always write the word next to it so that it's clear. And with the function f is increasing. Where will this be increasing?
Infinity to infinity.
Yep, it's always increasing. No matter which point you're standing on, move to the right and you always go up, right? So negative infinity to infinity. It's never decreasing, ever. Right? There's no one point where you can move to the right and decrease. Yeah, so it's good. Right. Okay, so this is okay. So now let me put a little remark here. This function, the exponential functions, are the fastest growing functions. They grow really, really fast. Sometimes it takes a while to rise up, but they rise pretty fast after that. The only problem would be what will happen if you plug in a fraction. So here we have 2 to the x, right? But what if you have, instead of 2, we had 1/2 to the x? And we can talk about that after we come back. And for now, just know that we're going to get these informations from it. If you notice, exponential functions will always have a horizontal asymptote, right? And we will talk about when we shift things for these functions. Anyway, so let's take a 20-minute break. It is now 10:40, so we'll be back at 11th, right?